Hello, my name is Vaclav and I'm from Department of Irrigation, Drainage and Landscape Engineering from Faculty of Civil Engineering, Czech Technical University in Prague. The title of our poster is the development of the methodology for flood frequency estimations in small catchments with use of geostatistics. First of all, I would like to present the methodology in general. The methodology is dedicated to be a tool for engineers who are working on some studies, not on design projects, because for design projects it's a duty to use the data provided by Czech Hydrological and Meteorological Institute in Czech Republic. So it's only for rough estimates of peak discharges with different return periods. The shape of methodology is shown here. It's a product of some mathematical functions of catchment descriptors as well as of some precipitation characteristics and one of the most important catchment descriptors is the catchment area. Here we are presenting the analysis of the relationship between the land use in catchments and the peak discharge, which is in the formula this function. So we are somehow trying to describe the relationship between land use and peak discharges. We can do that in two ways, which we are using both. First is hydrological modeling, which is better in that way that we can avoid the influence of the other catchment descriptors. And another approach is to use and evaluate the real data. Here we are presenting the second approach. We have used a data set of about 200 small catchments up to 150 square kilometers, which are located in South Bohemia and South Moravia. And as an input for the land use assessment, we have used Corina land cover data set from 2006. To quantify the land use or the descriptor, we have used the runoff coefficient, which is published in literature, and this is the map of runoff coefficient which was used to calculate the catchment descriptor value for each catchment. At the end, we related some value representing peak discharge to the average runoff coefficient in the catchment. We have used two different representations of peak discharges. First is relative peak discharge, which is the relationship between the peak discharge and the average discharge, and the other one is the specific peak discharge, which is simply calculated by dividing the peak discharge value by the catchment area. Here we can see that first the relationship is not very clear because of the influence of other factors or other catchment descriptors, and but there is some relationship which can be understood as reasonable. When we look at these plots or charts, we can see that we can't use it because with increasing average runoff coefficient, we we have decreasing specific discharge, which is not reasonable according to the methodology of runoff coefficient and rational formula. So this is only a part of our research. We are only at the halfway, and we have to do such type of analysis for also the other catchment descriptors. We did already this analysis for slopes and shapes, and we also did the analysis using hydrological modeling, which is much clearer, but it's not presented unfortunately here. So this was a brief introduction of our poster. Thank you very much for your attention.